All right, ladies and gentlemen, welcome to the third and final part of our introduction to atoms. And today we're going to be taking a look, traveling a little bit back in time again, and this time looking at John Dalton's theory that had the four postulates, and take a look at perhaps some things that weren't quite correct. It's actually amazing how much he did have correct, but there are a couple of things that he had wrong in his postulates. And so the first thing, one of his postulates said that all elements are composed of indivisible atoms, made up of indivisible atoms, meaning that those atoms can't be broken into smaller parts. Well, we now know that atoms have smaller parts. They are made up of protons, which are positively charged, neutrons, which are neutral in charge, and electrons, which are negative in charge. And we know that we can actually take these different parts of an atom apart. And we also know that these parts are made of even smaller parts called quarks, and that quarks actually, we believe now, may be made of even smaller particles than that. So the fact that he said that an atom was indivisible was actually incorrect. We also now know that not all atoms of the same element are identical. He believed that, for instance, all chromium atoms were exactly the same, or all potassium atoms were exactly the same, or all hydrogen atoms were exactly the same. We now know that that's not necessarily true. We do know that all atoms of an element have the same number of protons. For instance, oxygen. Every single oxygen atom has 8 protons. That's what makes it an oxygen atom, is the fact that it has 8 protons. All carbon atoms have 6 protons. All right, we know how many protons an atom has, and when it has a certain number, we can then tell by looking at the periodic table what element that is. However, all oxygen atoms have 8 protons, but they might not all have the same number of electrons. They might not all have the same number of neutrons. If they have different numbers of neutrons, we call those isotopes. So there are different isotopes for oxygen depending on how many neutrons they have. Always has 8 protons, but could have different numbers of neutrons. Could also possibly have different numbers of electrons as well. Don't talk about that here on the screen, but those are called ions, and we will be talking about those later on. Really, considering how long ago it was he made these postulates, he had a lot correct. It was pretty impressive considering the fact that he had no way of seeing an atom. He was able to determine a lot of things, but these two things were incorrect. All right, so we're going to start to fill in a little chart about what we know about some of the subatomic particles of an atom now. We're going to start with the proton. And a proton has a symbol that we use for it. It's a lowercase p with a positive symbol or a plus symbol next to it. It has a charge of positive 1. All right, and then we call its relative mass 1. Doesn't mean its mass is like 1 gram or something like that. Protons are so incredibly tiny, we can't really give it an actual mass. So we're just going to say it's 1, and then we're going to compare it to the other particles in an atom. There is another column on your chart. It's called location. We're going to get to that in a minute. We're going to fill in these columns first. So the next thing we're going to look at is the neutron. Neutrons are neutral. Therefore, there is no positive or negative next to the symbol. It's just a lowercase n. And the charge is 0. It has no charge. It's not positive, it's not negative, it's 0. Its relative mass is also 1, which basically means that a neutron and a proton are the same size. Then there's the electron. The symbol for the electron is a lowercase e with a negative symbol or a minus symbol after it, because electrons have a negative charge. The charge of an electron is negative 1. That seems reasonable, but it's actually kind of remarkable, because the fact is an electron and a proton have the same amount of charge. It's just opposite. One's positive, one's negative. Even though the electron is much, much smaller than a proton or a neutron. Okay, an electron is 1/1840th of a proton or a neutron. It takes 1,840 electrons, put those together, and that's the size of a proton. So electrons are incredibly tiny, and yet they still have the same amount of charge as a proton, just the opposite charge. Now let's talk about where these particles are in an atom. Protons are found in the nucleus, that's in the center of the atom. Neutrons are also found in the nucleus. You can find them together in the nucleus of an atom. Electrons, well, this is a little more tricky. Electrons are in what we typically call, and there's still a lot we don't know about electrons, so this is what we believe to be true at this time. Electrons are in what we call an electron cloud. Protons and neutrons are pretty, they don't really move, they're stable. Electrons are zipping all around in this cloud outside of the nucleus, and that kind of surrounds the nucleus. And then there seem to be levels inside this cloud, and so you have some electrons that are in a level that's close to the nucleus, and then you move out and there's another level. You move out further and there's another level, and there are different numbers of electrons in each of these levels. One of the crazy things to think about, and again, this is to a certain extent some speculation at this point, but we believe it to be true that electrons can really move great distances and still be considered to be a part of a certain electron cloud of a certain atom. It might even be possible for an electron of an atom that is a part of your body to currently be on the other side of the moon and making its way back. It's a little strange to think about, but we think that may be true. We're going to talk a lot about neutral atoms and then charged atoms later on. For right now, we're going to talk about neutral atoms. And what makes an atom neutral is when it has the same number of electrons and protons, when the positive charges and the negative charges balance out. Eventually, we'll talk about atoms called ions, which either have a positive charge or a negative charge. We're not getting to that quite yet. It'll be just a few days before we get to that. For right now, if I don't say that an atom is positive or negative, then you should assume that it's neutral and that there are the same number of protons and electrons. For instance, a neutral oxygen atom is going to have 8 electrons because every oxygen atom has 8 protons. That would make it neutral. All right, ladies and gentlemen, we're going to continue on talking more about atoms, but this is the end of our lesson on an introduction to atoms and the history of knowing about the atom. Have a great day.